In this short video, we're going to extend our Lewis dot structure from a previous video, and we're going to use it to explain ionic bonding. Ionic bonding is going to be the interaction of a metal with a nonmetal. So in this example, we have lithium as a metal, and we have fluorine, oxygen, and nitrogen as nonmetals. So we can write here metal, nonmetal. Okay, so from our Lewis dot structure up here, we know that lithium has one valence electron. From our Lewis dot structure up here, we know that fluorine has 7 valence electrons and one box, which means it can accept one electron. When metals and nonmetals encounter, the nonmetal is the element that makes decisions and now calls for this electron to go into that box. So this electron goes into that box. The lithium now has been deprived of its electron. So we have lithium. The lithium now has lost its negative electron, so it acquires a positive charge. The fluorine now has been surrounded by the extra electron. So it's got its original 7 dots. Now its box is full. So because fluorine now has 8 electrons, it's picked up that extra electron, which is now manifest as a negative charge. And most chemists would just write LiF. Notice this is in a 1-to-1 proportion, meaning there's one lithium and one fluorine in the ionic compound. This is known as Joseph-Proust definite proportion. Joseph-Proust definite proportions. Okay, let's repeat again for lithium and oxygen. Lithium has 1 valence electron. Oxygen up here has 6 valence electrons and 2 boxes, so it can accept 2 valence electrons. The problem is, although oxygen can accept 2 electrons, lithium only has 1 electron to offer. Well, that's okay. We just need 2 lithiums because every box in the nonmetal must be filled by a metal's electrons. So I can add the coefficient 2. This just means I have 2 lithiums. So therefore I have 2 lithium valence electrons. So one of them is going to go here and one of them is going to go here. So I've now got 2 lithiums. They both acquire a positive charge because they both lose their valence electron. There's an exchange of electrons with oxygen. And oxygen now has its original 6 valence electrons plus the 2 electrons it acquired from 2 lithiums. So one of these electrons came from one lithium. The second electron came from the second lithium. Because oxygen picked up 2 electrons, it acquires 2 negative charges. So we have 2 positive charges and 2 negative charges. So the ionic compound is electrically neutral. Ionic compounds must always be electrically neutral. The way a chemist would write this, the coefficient becomes a subscript. So you would write Li subscript 2O in a 2-to-1 Joseph-Proust definite proportion. And finally, we'll repeat for lithium and nitrogen. Once again, lithium has a valence electron, shown here. Nitrogen, as we can see here, has 5 valence electrons. and 3 boxes. We need 3 electrons to fill nitrogen's valence shell, so we need 3 lithiums. So we have 3 separate lithiums, each of which donate or exchange their electrons with the 3 vacancies in nitrogen. So if we come over here and we can write the 3 lithium, the lithiums now don't have any valence electrons. The nitrogen now has picked up 3 extra electrons. So the 3 boxes of nitrogen are now filled with the 3 electrons from lithium. The addition of 3 negative electrons is now a negative 3 charge. So I have 3 positive charges and 3 negative charges. So again, an ionic compound is electrically neutral. A scientist would just write Li3n, where the coefficient 3 becomes a subscript 3, and we have a 3-to-1 Joseph-Proust definite proportion. So in summary, here we've shown our understanding of ionic bonding between metals and nonmetals using Gilbert Newton-Lewis's dot theory, where the dots represent valence electrons, and we're able to predict the Joseph-Proust definite proportions, which gives you the formula of the chemicals, and now you can learn to predict them.